As you know, I was talking about this is the Kunisberg. That is based on the Euler path. Okay. Here you have to return to the starting point by traveling each link of the graph only once and only once. Okay. So if you see this is the example of Eulerian path where every vertex of this graph has an even degree. Okay. So you can find that each node has an even degree, and therefore it is a Eulerian graph. Okay. If a graph is strongly connected and the in degree of each node is equal to the out degree, then there is a Euler circuit. But in case of a network where there is a directed network, which is called a digraph, then in that case the in degree of each node should be equal to the out degree. Otherwise, there is no Euler circuit. So in a circuit, we need to enter each node as many times as we leave. Now, if you see the pathology, you will see that if you trace this one, a sequence of nodes such that each node is connected to the next node along a path by a link. So you can start from 1, then 2, then 5, then 4, then again coming to 2. So this is the node, how you are going by a node. But another could be any path you can trace. But if you are going for a shortest path, you have to find that which one is the shortest path. Like for example, if you want to go 1 to here, 1 to 4, like this you can go. You can also go 1 to 4 like this. Okay? Or you can go by 1 to 4 by this. So the distance which is the shortest one will be treated as a shortest path. So this is how diameter is measured. So you have to start, for example, this is 1, this is 4. So you have to measure the distance between these nodes, and the longest shortest path is the diameter of the graph. And the average, if you see the average path length, that is you have to add all the lengths like L1 to 2, L1 to 3, all the path length you have to see, and then you have to divide by 10. So you can calculate the average of the shortest path of all pair of nodes. That is called average path length. There is a path, sometimes it is cyclic one. So a path that you start from the same node and end at the same node. So it will start and end at the same node. That is called a cyclic path. Sometimes a path avoid a self-avoiding path. So it will not come back again. It will not come back again to the same node. It will go and it will avoid itself. This is called self-avoiding path. This is the Eulerian path. Eulerian path traverses each link exactly once. So, and Hamiltonian path visits each node exactly once. So what is the basic difference? Basic difference between Eulerian is that it will move or it will traverse through each path only once, whereas Hamiltonian path, it visits each node exactly only once. So when you see the connected graph where any two vertices can be joined by a path, a disconnected graph is made up of two or more connected components. Now you can see here, this is a graph, okay? This is a connected one, If I disconnect here, this red one, this bridge, if you can disconnect, then it will become disconnected. So the main component is known as the giant component of the graph, whereas the smaller one is known as isolates. There could be more smaller one, but here we are showing only one. So this is isolate and this is a giant component. And the adjacency matrix of a network with several components can be written in a block diagonal form so that non-zero elements are confined to squares with all other elements being zero. Therefore, there are certain strongly connected graphs that has a path from each node to every other node and vice versa. Now, weakly connected directed graph, they are connected if we disregard the edge direction, and a strongly connected component can be identified, but not every node is a part of a non-trivial strongly connected component. So there are many nodes in that directed graph. Now, ultimately, we are coming to the three central quantities in network science. One is the degree distribution. So I've already discussed about degree distribution, that is pk, the probability of a k. There's another one is average path length, and the third one is the clustering coefficient. Okay. Now let us see what is degree distribution. You can see here that we have a sample of values x1 to xn. Now distribution of x, that is the probability and the density function. The probability that randomly chosen value is x, so you can plot it in form of histogram. Okay. So if you see here degree distribution, that is the pk, the probability that randomly chosen vertex has degree k. So what we are doing here, we are computing the probability of k, and these are the degrees of k. So this is 1 degree, this is 2 degree, this is 3 degree, this is 4 degree, and so on. So we can plot them based on the degree of the network, and this is called degree distribution. And there could be a continuous representation of degree distribution, that could be a discrete distribution also. Another property is the clustering coefficient. Now you see here what portion of your neighbors are connected. So as I told you, whether your neighbors are connected or not, if the neighbors are not connected at all, for example, you see here the clustering coefficient is 0. Here some of them are connected, some of them are not, so it is 0.5. And here all neighbors are connected, and therefore the clustering coefficient is 1. Okay, I hope it is clear to you. So now we have a formula for the distribution. This is the path length, and this is the clustering coefficient. This is not that important. Yeah. So these are the areas I wanted to discuss with you. Now I will show you the material which I want to give it to you. So this is about graph theory. So I'm sharing. Okay, first let me display it. Then I will share. Yeah, now you can see that. So this is a book chapter written by Barabasi himself, where he has explained the bridges of Konisberg, and from that he has also explained what is network and graphs, and how these networks and graphs are connected, and then some sort of and then degree, average degree, and degree distribution concept is described here. Okay? And then this adjacency matrix is there. So you can see here, as I was telling you, that most of the adjacency matrices are sparse. And you can see here that this adjacency matrix is sparse in nature, because these dots, no, these dots shows the dots means one, okay, means there is a connection. And if it is empty, nothing is there, it means that it is zero. So therefore, they have created adjacency matrix of yeast protein-protein interaction network consisting of 2018 nodes, each representing a yeast protein, and dot is placed as each spot of the adjacency matrix for which Aij is 1, indicating presence of an interaction. Yeah, and there is no dots for Aij 0. A small fraction of dots underlies the sparse nature of the protein-protein interaction network. So you can see here the adjacency matrix and the interaction network. So this explains the adjacency matrix, which I already have talked, and then weighted network, unweighted network are there. Bipartite network, I have already talked. And then paths and distances in network, like shortest path, average path length, network diameter, Eulerian path, Hamiltonian path, all are there. Then connective mechanism component, clustering coefficient, and there is a summary. Also, there is something about global clustering coefficient, because we not only compute the clustering coefficient of each node, but we also compute the clustering coefficient of a whole network. That is called global clustering coefficient. So this I am sharing with you in your classroom. So now you can see your classroom. I have shared the material with you, whatever I have discussed. Have you got the material?
Yes, sir.
Yeah. So you go through it, okay, and try to understand the concept. So today I won't extend class for longer period because, as you know, I was sick yesterday, so now I am a little better. So hopefully, not today I will be okay. So you just go through the concepts, and if you have any queries, you can ask me in the next class. Okay. You have any questions regarding whatever I have discussed? Okay. If you don't have any queries, I will just give you attendance. I think all of you are present today. Not all. Only 14 people are present. What is there? Arnav is there. Pablo is there. Chandrika. Is there. No. Nothing. Nasi. Messi. Radia. Tis. Bash. Vedavana. Vishal. So, your.
Excuse me, sir.
Yeah. Chandra is there.
Yes, sir.
You are not visible?
No, sir. Sir, I right now I'm at vaccination center for second dose.
Oh, you went for vaccination today?
Yes, sir.
Okay, from there you are calling. Okay, good. No problem. I am giving you your address. Go ahead.
Okay, sir.
Okay, thank you.
Thank you, sir.
Any other person? Megha? Megha is absent today. And Subhashis is also absent. Okay, so if you don't have further queries, I'll close today and we will meet in the next class. That's on Wednesday, no? Yeah, Wednesday.